Okay, I'm going to go over section 9.3 in this short little video to help you as you're working on the problems from that section. So in this section they're talking about modular arithmetic, and the set of elements in this set from 0 to 11 with an operation of addition is called a modulo 12 system or a mod 12 system. And a modulo m system contains of m elements from 0 to m minus 1 and a binary operation. And so if we look at modulo 7, for instance, and look at here the days of the week, so modulo 12 would be for the months of the year. Modulo 7 would be the days of the week. And so if we notice over here, we go from Sunday, Monday, Tuesday, etc. And to work the problems, let's take some problems on the days of the week. So let's assume Sunday is represented as day 0, Monday is day 1, and so forth, just like we just showed on the prior slide. So you might want to keep that handy when you're working on the problems. So if today is Thursday, which is day 4, determine the week it will be in the specified number of days, and we're going to assume there weren't any leap years. So in 43 days, where would we be? So what we're going to do is we're going to divide by the value of the modulus, in this case 7 days in the week. So 43 divided by 7 gives us 6 with a remainder of 1, and that's written in this form. This is the remainder, and then we identify the modulus. And so if we were on a Thursday currently, in 43 days, we would go 1 day further and would be a Friday. In 3 years. So we need to convert the years to days. So 3 times 365 gives us 1,095 days. Again, we're going to divide by 7. And we get 156 with a remainder of 3, which is written like this, 3 mod 7. So if we're on a Thursday, we're going to be 3 days ahead, and that will be in a Sunday in 3 years from today on a Thursday. Now let's do the modulo 12 for the months of the year. So if it's currently October, determine the month it will be in the specified number of months, in 73 months. So we're going to go ahead and divide by the modulus, which is 12. And we get 6 remainder 1, which we can write like this, 1 mod 12. And so if we're currently in October, in 73 months, it will be November. In 4 years and 8 months. So again, convert this all to months. So 4 times 12 is 48 plus 8, 56 months. Divide by 12, and we get 4 remainder 8. And so we're going to be at mod 12, and so we're going to be 8 positions earlier, and that will be June. 8 positions ahead, I'm sorry. In 4 years and 8 months, it will be June. So that would be counting 8 ahead from October. Okay, another one here. Dusty's a chef at a restaurant. His working schedule is to work for 6 days, and then he gets 2 days off. If today is the 3rd day that he's working, determine if he'll be working in 60 days from now. Okay, so since he works 6 days and then has 2 days off, this is actually a modular 8 system. So in other words, his cycle of working goes 8, 16, 24, etc. So take the 60 days that we're interested in and divide by 8, and we get a remainder of 4. And here's his cycle. Remember, he works 6 days and then he's off for 6 days. And they told us that today is the 3rd day in his cycle, and so we're going to move ahead by 4. And so in 4 days ahead, he would not be working. Now we want to know if he'll be working 82 days from now. So again, divide 82 by 8 to get 10 with a remainder of 2. So again, if we look 2 days later in his schedule, he's on day 3, he would be on day 5, and he would still be working. Today is the 3rd day. Determine if he was working 124 days in the past. So you're still going to divide by 8. So 124 divided by 8 gives us 15 with a remainder of 4. Now we got to go backwards. So here he is working. He's in the 3rd day of his cycle, but we want to go back by 4. 1, 2, 3, and 4. So 124 days earlier, he was not working. Congruence. Congruence. A is congruent to B in a modulo M system if A and B have the same remainder when we divide by the modulus. In any modulo system, we can develop a set of modulo classes by placing all the numbers with the same remainder in the appropriate class. The solution to a problem in modular arithmetic, if it exists, will always be a number from 0 through m minus 1, where m is the modulus of the system. So when we were dealing with the 12 months of the year, we went from 0 to 11 because the modulus was 12. And here's those modulo 7 classes again. So if I look down here in this class, all these numbers in modulo 7 have a remainder of 1. All these numbers have a remainder of 2, and so forth. We say these numbers in one column are congruent to one another because they all have the same remainder. Determine which number from 0 to 6 the following numbers are congruent to in a modulo 7 system. So let's take them one by one. Let's take 60 first. And here's how the question would be written out. We want to find the remainder. So you're going to take 60 and divide by 7. We get 8 remainder 4. So the 60 is congruent to 4 mod 7. How about 84? We're going to take the 84 and we're going to divide by 7, and we get 12 remainder 0. So we write this as 84 is congruent to 0 mod 7. 412, again, divide by 7. We get 58 remainder 6. So 412 is congruent to 6 mod 7. Evaluate each of the following in modulo 6. Now, notice on the left-hand side we're adding. So we can go ahead and do that addition, and we get 8, and we want to know what that's congruent to in the modulo 6 system. So we're going to take 8 and divide by 6, and we get 1 remainder 2. So therefore it's congruent to 2 mod 6. 5 minus 2 is congruent to what in the modulo 6 system? So we can go ahead and subtract there. So 5 minus 2 is 3, and so our answer is simply 3 mod 6. And 6, we always want this, okay, let's do a couple more here. Determine the positive number replacement less than the modulus. So we always want a positive number when we're doing our congruence here for the question mark that makes the statement true. So let's do the first one. Let's go back for a second. The first one said 3 minus 5 is congruent to what in the modulo 7 system? Now, notice on the left side here, if I do the subtraction here, I get a negative number, which is not going to help me over here. So what I can do is add the modulus to come up to a positive number. And so, for instance, what I'm going to do on the left-hand side is add 7 here to 3. It's going to take me up to 10. 10 minus 5 is going to give me 5. So this is going to be congruent with 5 modulo 7 system. I can't use a negative number here. The number I replace here has got to be a positive number. So what I did here was simply go through the cycling to come up on basically on one of those tables to the next row on the table. I'm adding the modulus, which doesn't change the remainder. And how about this one? What do I have to subtract 4 from in order to get 3 modulo 7, or a number that's congruent to that? So we want to replace this with a number less than 5 because the modulus is 5. So we need to determine what that number is such that the number, actually 7, is congruent to that. So let's take a look here. So if I put a 7 in here, 7 minus 4 is 3. Take away the modulus 5, right? Because this would give me a true answer. But if I take away the modulus 5, I actually can write it like this, and so therefore, oops, let me go back for a second. The answer didn't come up for you. Sorry about that. The answer there should be simply written this way, because we're looking for this number here. There's the final answer right there. So if we put a 2 in there, we would get a negative over here, add the modulus, and it'll take us back up to the 3, because 2 minus 4 is negative 2. Add the modulus 5, we would get back to the 3. And then the last one, 5 minus what, is congruent to 7 mod 8. So again, adding an 8 here. So if we add an 8 there, let's go to the next slide. Add an 8, so 8 plus 5 would give us 13. What do I subtract from 13 in order to get 7? I subtract 6. So therefore, the answer would be, now again though, I want to get back to the original problem, so I'm going to go ahead, because we started with a 5, and subtract the modulus and go back to 5. So it's going to be 5 minus 6 is congruent to 7 modulus 8. Let's try a multiplication problem. 5 times 8 is congruent to what in the modular 4 system? So find the product, it's 40. Divide by the modulus 3, and we get 13 remainder 1. So 5 times 8 is congruent with 1 mod 3. And that's the short presentation I was going to give you on the modular arithmetic for this week. So hopefully this will help you as you're going through your homework problems.